All right, for this question, nitric acid is an acid, but it's HNO3. They want the mass of it. That's the same thing as asking for the grams. We have a volume and we have a pH. So if I want the grams, I know I'm going to need the moles so that I can use this formula. I'm going to be able to get the moles by using molarity equals moles over liter. If you don't like working backwards like that, and you just say, well, I have pH and I have liters, you don't know what to do, well, we have the pH. Something we can find from pH is the molarity of the H+. It's just something we can do that might be helpful. We're working with an acid, so it's reasonable to think that we'd want to find out something about H+. So H+ is 10 to the negative pH, or 10 to the negative 2.3. When I do that on my calculator, I get 0.005. Now that's the molarity of my H+, but because we have a 1-to-1 ratio, all of our strong acids that we do math with are 1-to-1 ratios, there's only one hydrogen there. This is also the molarity of my nitric acid. That's helpful because that molarity of nitric acid will help me find the moles of nitric acid, since I know that I'm in 2.5 liters, that was given in the question, of nitric acid. So I take this, I multiply by 2.5, that gets me my moles of nitric acid to be 0.0125. I want the grams of nitric acid, so I plug in the moles of nitric acid and the molecular weight. It should be 1 plus 14 plus 16 times 3. Your molecular weight should be 63. Sorry, I realized that one looks like a 6. So it's 0.0125 times 63. We get an answer of about 0.79. On the answer key, I rounded it to 0.8. That's it.